So can you see my PowerPoint?
Yes, sir.
Yes, sir.
जी सर.
So yesterday we were talking about half adder circuit, where we found that for a half adder circuit, what was the equation for sum and carry? For sum, we got the equation of S equals to A exclusive or B, right? And
Yes, sir.
carry, we got the equation C equals to
A times B.
divided by B, right? So if you draw the circuit, if we have a input A and B, so from A and B we connect this input to a exclusive OR gate, then the output of this OR gate would be A exclusive or B. Similarly, if we take that to a AND gate, the output of that AND gate would be the equation for your carry, and the circuit within that dash line box is your half adder circuit, which is given by this block. We have derived the condition yesterday, right? So is there any question regarding this? So I'm assuming there is no question. And for the full adder circuit, what we got for the full adder circuit, the equation for sum, we got A exclusive or B exclusive or C in, right? And the equation for C out, we got A multiplied by C in plus B multiplied by C in plus AB. That was the equation for sum and carry. So if we design the circuit, what we have, we have three inputs A, B and C in. So first we will connect A and B to a exclusive OR circuit, and the output of this circuit would be A exclusive or B. Then we'll put this input as one of the inputs of another exclusive OR circuit, which output would be S2, and we'll put this C in as the second input of this circuit. So the output of this exclusive OR gate would be A exclusive or B exclusive or C in. Similarly, if we want to have a circuit for C out, what would be the circuit of C out? The circuit of C out would be a summer circuit. So we'll need a OR gate whose input will be coming from three AND gates. The first AND gates here, the second AND gates here, and the third AND gates here. And the input of the first AND gate would be from A and B. So we are taking B from here and we are taking A from here. So the input of the AND gate would be AB. Then the second input, it should be B multiplied by C in. So we can take from here, this should be your B, and if you take the input from here, it should be B multiplied by C in, and the third input, it should be A multiplied by B in C in. So I can connect C in from here, and I need to have A. So A would be coming from here. That should be your A multiplied by C in. So all the circuit within this dash line would represent your full adder circuit. Is there any question regarding this circuit? We have already discussed and explained everything in the class yesterday, and I am just recapping the basic concept of it today. So is there any question regarding this today?
No, sir.
Okay, so now what I will try to do, I will try to make a full adder circuit using a half a one or two half adder circuit. So if we take two half adder circuit, suppose we have one half adder circuit here, that is your half adder circuit, circuit 1, and it should have two inputs and two outputs. That should be your sum 1 and carry 1. Similarly, you will have another half adder circuit, that will be your half adder circuit 2, and it should have another two inputs and two outputs, S2 and C2. Now for the full adder circuit, how many inputs you have? 3, right? A, B and
C in.
right? So now if I put A as an input here and B in the second input, the output of the half adder circuit S1, it should be A exclusive or B, right? And the output of this carry circuit should be multiplication of the inputs, so it should be AB, right?
Yes, sir.
Now if we directly connect this as the first input of the second half adder circuit, and if we connect C in as the second input of this of the second half adder circuit, then what should be the output of S2? It should be A exclusive or B
Exclusive C in.
exclusive or C in, right?
Yes, sir.
And what should be our C2? C2 should be the multiplication of both inputs, right? So it should be A exclusive or B multiplied by C in, right?
Yes, sir.
So let me erase this and write it down. Here C2, it should be A exclusive or B multiplied by C in. So now what we are doing here, as you can see, the sum output, it represents the output of the full adder circuit, because in the previous slide what we said here, the output of the full adder circuit should be exclusive or of the three inputs, and here using that two half adder circuit we are getting the same output, but the carry is different, right? So what we can do here, so suppose if we take C2 and if we take C1 here and then we add them in a summer circuit, this should be your C out. And what would be the equation of the C out?
AB plus AX or B C in.
A XOR B multiplied by C in plus
AB.
If we can anyhow prove that this circuit is equivalent to my AB plus A into C in plus B into C in, then we can say that this circuit is similar to what we have in a full adder circuit. You are understanding my point, right?
Yes, sir.
So let's take this equation and write it down here. A exclusive or B multiplied by C in plus AB. So for this part, what we can write, A B bar plus A bar B multiplied by C in plus AB. So A B bar C in plus A bar B C in plus AB. So what we can take in common between the last two terms?
B.
So if you take B common, then we can have A plus A bar C in, right? So what we can write, A B bar C in plus B multiplied by this is similar to my x plus x bar y. It should be your x plus
X
y.
plus
We have
Y.
learned this postulate, right?
Yes, sir.
So we can write A plus C in. So similarly, A B bar C in plus A B plus B multiplied by C in. So from here, if we write down here, we can write, so from the first two term, what we can take in common now?
A.
A.
Did I make any mistake?
No, sir.
Okay. So now we can write A B plus C in, then B into C in. So finally we can write AB plus A multiplied by C in plus B multiplied by C in. This equation. So we can write and prove that we can make a full adder circuit using two half adder circuit, although we are getting directly the sum equation as similar to what we have for full adder circuit, but in order to have the C output, what we need to do, we need to have two carry combined in with a OR gate. Do you understanding my point, what we have done here?
Yes, sir.
Is there any question so far?
No, sir.
Okay. So now we'll try to learn about two methods that is normally used for subtracting a number from another numbers. And this method I believe you have learned previously. Is there anyone who haven't heard about this method, ones complement and twos complement? Is there anyone?
No, bhai.
Okay, so for the ones complement method, what we need to do, if I take 1a, this is my number, so 0 0 0 1 1 0 1 0. If we want to take the ones complement of this number, what we need to do, we just need to replace 0 with 1 or 1 with 0. In other words, in a simple word, we can say we just need to complement the number what is given here. So wherever you have 0, we just need to replace that 0 with 1, and whenever we have 1, we just need to replace that 1 with 0. You are getting my point, right?
Yes, sir.
One's complement should be 1 1 1 0 0 1 0 1. That should be your one's complement. Is there any question so far?
No, sir.
Similarly, for number 2, the actual number is this. So 1 1 1 1 0 1 1 1. So if I take the ones complement of this number, we'll get 0 0 0 0 1 0 0 0. That will be the ones complement of this number. And for the third one, we can write 1 0 0 0, then 1 1 0 1. If I take the ones complement of this number, we'll get 0 1 1 1, then 0 0 1 0. So I think ones complement is a straightforward thing, and there should not be any question regarding this ones complement method, as you have learned it previously. Is there any question so far?
No, sir.
So now we'll learn how to get the twos complement of a number. So if you want to get the twos complement of a particular number, what we need to do in order to get twos complement, what we need to have, we have to do the ones complement first, and then we have to add 1 with the ones complement number. You are getting my point, right?
Yes, sir.
So if you do the first one, suppose 2a, so this is the actual number 0 0 0 1, then 0 1 1 0. If I take the ones complement of this number, what would be the number? 1 1 1 0, then 1 0 0 1. That should be the ones complement of that number. And if we add 1 with this number, we'll get the twos complement. And that number should be 0. 1 plus 1 gives you 0, and the carry should be 1. So it will come here, and the rest of the number will be as it is. That should be your twos complement. Is there any question so far?
No, sir.
Similarly, for the second number, if you want to have the twos complement of this number, so first we need to write down the number, and then we have to get the ones complement of this number. So we will get 0 0 0 0, and then 0 0 1 1. That should be the ones complement of this number, and then we have to add 1 with it. So we will get 1 plus 1 gives you 0, and there should be 1 here as a carry. So 1 plus 1 again gives you 0, and you should have 1 carry here. 1 plus 0 gives you 1, and then the rest of the number should be as it is. So this number is the twos complement of this number. You are getting my point, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So now this method is somewhat takes some time. So we need to learn some shortcut methods by which we can get the 2's complement without getting the 1's complement and adding 1 with it. So how can we do that? So now first I am taking this number. So what is your number? 0 0 0 1 0 1 1 0. So the shortcut number says we'll start from the right hand side until we get the first one. So where I get the first one? Here. So until unless I get the first one, the number will remain as it is. And once you get the first one, the rest of the number you need to take the complement of this number. So what is the complement of this number? 1 1 1 0 1 0. So this number gives it is this number, right?
Yes, sir.
Any questions so far?
No, sir.
Similarly, if you have this number, we can write 1 1 1 1, then again 1 1 0 0. So if we start from the right, we'll start until we get the first one. Here we get the first one, so the number will remain as it is until the first one number. And once we get the first one, then the rest of the number we need to take the complement of it. So what will be the complement of this number? 0 0 0 0, and for this one it should be 0. You see, this is the number given here. Is there any confusion so far?
No, sir.
So for the third one, what we can do? The actual number is 1001, then 0001. So what should be the 2's complement of this number? So if you start from the right, the first number is 1. So we'll keep the 1 as it is, and then we have to take the complement of the rest of the number. So what should be that number? 0 1 1 0, then again 1 1 1. That should be the 2's complement of this number. Is there any confusion or question so far?
No, sir.
No, sir.
Are you guys getting bored?
No, sir.
No, sir.
No, sir.
No, sir.
Okay. So we'll try to see what's the application of this 1's complement and 2's complement method. So in your computer, whenever you need to subtract something, what they do, they just make the 2's complement of the number that needs to be subtracted from the numbers. So they actually, once they have converted any number into its 2's complement, then what they do, they just add the number with the previous number, and they, by adding, they actually get the result what should be for the subtraction. So let me do one example and see how it works. So if I do the first one, suppose it says the number is 0 0 0 0, then 1 0 0 0. So what should be the number in decimal?
8. 8.
Right? And I need to subtract it from the number. What should be the number? 0 0 0 0, then 0 0 1 1. So it gives you 3, right?
3.
Yes, sir.
So if we subtract, what should be the outcome? 5, right?
Yes, sir.
So in 2's complement method, although we will be adding the number, but the result should be similar to what we'll get from the subtraction. So let me do that again. So if we get the number 0000 and then 1000, that should be your 8. And if we take the complement, 2's complement, so if we go from the right, we'll get 1 for the first digit. So 1 will be as it is, and the rest of the digit will take the complement of this number, right? So the number should be 1111, then 110. That should be your 2's complement of 3, right? So now if we add them, what I will get? 1 0 1, then 1 1 gives you 0, and we'll have 1 carry from here. So 1 1 again gives 0, then here we'll have 1 carry. 1 1 again gives you 0, we'll have 1 carry here. 1 1 gives you 0, again we'll have 1 carry here. 1 1 0, then we'll have 1 carry here. So the 9 digit we can neglect, so the rest 8 gives you what?
5.
5, right? You got my point, right?
Yes, sir.
Is there any question so far?
No, sir.
So whenever we have a positive value after subtraction, if we take the complement of this 2's complement of this number and we just add them, we'll get the exact result doing
Yes, sir.
addition, right?
Yes, sir.
Now let me do another example. Suppose we are doing B. So what's the number? 0000, then 1100. What should be this number? 12, right? Right?
Yes, sir.
And the last number that needs to be subtracted, what is that number? 1111, then 0111. What is this number? What is this number?
7.
What's the number?
Is it 247?
How can you get that? How can you do that? We learned, right? So 1 multiplied by 2 to the power 7 plus 1 multiplied by 2 to the power 6 plus 1 multiplied by 2 to the power 5 plus 1 multiplied by 2 to the power 4. Then here we have 0. So 1 multiplied by 2a square, 1 multiplied by 2 to the power 1, and 1 multiplied by 2 to the power 0. That should be your number.
247.
So it gives you 247, right?
Yes.
So the subtraction result should be minus 235, right?
Yes, sir.
Now, if we do that one's complement, 2's complement and add them together, what will happen now? So if I take the number again 0 0 0 0, then 1 1 0 0, and if we take the ones complement, we'll get first 1, so 1 will be as it is, and the rest of the number should be complemented, so it should be 0 0 0 0, then 1 0 0. That should be your number. That is the 2's complement. Then if we add them together, what we get? 0 1 0, then it will have one carry here, 1 0 0 0. What should be your number? Is it 235?
Giving 21, sir.
Right. This is not 235, rather this number is your 2's complement of 235. You got my point, right?
Yes, sir.
So whenever you have a output that is negative, if you do the summation, whatever outcome you get, it is not the exact number what we have got in the previous case. Rather, it would be the 2's complement of the actual number. So how can we get the actual number? If we take again the 2's complement of this number, then we will get the actual number. You remember, right? A bar, if you take again bar, then you will get the actual number, right?
Yes, sir.
So what will be the 2's complement of this number? 0 0 0 1 0 1 0 1. So first we get 1, and the rest of the term it will be complemented. So 1 1 1 0, and then 1 0 1. This should give you 235. Check.
Yes, sir. 235.
So what we have learned here, if we do the summation, and the summation, although it is doing the subtraction, we are getting some positive number, then the number itself represents the actual number. But if we do the summation and the actual output is negative, then you will not have the actual number, rather you will get the 2's complement of the actual number. And in order to get the actual number, what we need to do? We need to again
Yes.
2's complement of that number to get the actual or real number. You got my point, right?
Yes, sir.
Yes, sir.
So in the next class, which is tomorrow, we'll try to get some circuit that is used in your computer to do the addition and subtraction at the same time. So based on your command, you can either add two numbers or you can subtract two numbers using the same circuit. So we'll do that tomorrow. So what I will suggest you just go through the content we have learned yesterday and today, so that you will be prepared for the class tomorrow. If there is no question today, then you are good to go.
Thank you, sir.